Welcome to the Alva Training and Consulting's online training program. Today we're going to answer the question, what is SPC? Please keep us in mind for all your ASQ certification preparation needs. We have been teaching students and preparing them for ASQ certification for over 20 years, and we have become very good at it. So let us know if we can help you in that area. All right, back to the question, what is SPC? SPC is an acronym for Statistical Process Control. SPC is used to keep processes in control, which means to keep them predictable. Remember, we can't do math or analytics on something that's unpredictable, so it's very important to keep our processes in control or predictable by identifying when special causes are present, so you can adjust them from the process. Remember, special causes are unpredictable. And if it's a special cause, you can usually assign the cause. In other words, you know what caused it. An operator switched the switch up instead of down. That created some problems. Okay, you can assign a cause to it. It's also special cause is also called assignable cause variability. I know we've already had a video on this, but this is just a reminder. Normal cause, you cannot adjust it out of the process. If you want to reduce normal cause, you have to redesign the process. So that's the difference between the two. Normal cause is predictable, special cause is unpredictable. Remember, we like to keep our processes predictable. What do we call predictability in the world of manufacturing or in the world of processes? Predictability means it's in control. In control means predictable. Okay, remember SPC is based on probability statistics. You'll need that information here in just a little bit. Here's an SPC chart, and the upper control limit and lower control limit, average, that's all part of an SPC chart. And the upper control limit, by the way, is always 3 sigmas or 3 standard deviations away from the average. And as you can see, the formula is very simple. Upper control limit equals what? The average plus how many standard deviations? 3 standard deviations. So there it is. Those are not very difficult formulas to remember. The lower control limit, of course, is average minus 3 sigmas. And so there you go. Remember, SPC is used to determine what kind of variation is present? Special cause. Why do we want to know about that? Because you can adjust it out. So a lot of times the operators run this, and when it shows an unnatural trend, which means there's a special cause present, they know when to adjust the machine and when not to adjust the machine. Remember, you can adjust special cause out. You can't adjust normal cause variation out. SPC, also another way of looking at it, it's used to answer the question, did something change? A lot of times we use it in our Six Sigma projects to show what the process looked like before we made any changes, implemented the improvement. And so it'll show where it was. And then after we make the improvement, maybe this is on yield, and of course we like higher yield out of process, so we're plotting along here, and this shows the baseline of the process. Then after we implement the solution, we'll continue and put the data here. What this chart, we hope this chart shows from a Six Sigma black belt student's perspective, is we hope to show that, wow, look how everything shifted up, and shows that we get higher yield after the improvement. And of course, we know what we did to improve it, so that's a special cause. But it answers the question, did something change? Did it statistically significantly change? And how do we answer those questions? Well, it's really quite simple. That's the advantage of SPC. You can do statistical analysis. In other words, say that there's a statistically significant change. You don't have to be a statistician. Operators can do this with a small amount of training. What do they look for? Well, a special cause is suspect when 1 or more points are above the upper control limit or below the lower control limit. So remember, plus minus 3 sigma, that's where 99.73% of the data should lie. So if you get one outside the control limits, it's highly likely to be a special cause. So that's pretty easy to do that analysis. A special cause is suspect if 8 or more consecutive points are above or below the center line. So if you get 8 or more consecutive points above or below the average, that is considered to be a suspect special cause, and you can adjust your process back to center. Now, And remember, this is based on probability statistics. This is a symmetrical distribution. So there's a 50-50 chance that you'll get a point above the average or below the average. By the way, we usually plot average values on this chart. But with that being said, 50-50 chance, that's the same as flipping a balanced coin, right? Well, would you suspect that something was wrong if you flipped a coin and 8 consecutive trials you got a heads? You'd think, wow, something's wrong with this coin. You look at it, hey, heads is on both sides, no wonder, right? But it's the same thing with SPC. To get 8 consecutive points above the average, that would be very unusual unless something in the process has changed, shifted upward, for example. And it's the same way with downward. 8 consecutive points below also suggests that there's been a change in your process and it's statistically significant. There's a special cause and you may be able to adjust that out. There you go. A special cause is suspect if 8 or more consecutive points are above or below the center line. Third, a special cause is suspect if 1 or more in 20 plotted points is in the 1/3 outer edge of the chart. Well, 1/3 outer edge means 1/6 on each side. In other words, 1 sigma outer edge of this chart, you shouldn't see very many points. Why? Well, look how short those lines are compared to the lines over here. Let's see how big those that is right there. So you shouldn't see many out here. That's the point. And so if you see more, suspect if 1 or more in 20 plotted points is in the 1/3 outer edge of the chart. A special cause is suspect if movements of 6 or more consecutive points are either up or down. So if an operator sees 6 consecutive points going up, that's very unlikely that that's coming from a normal distribution. Therefore, there must be special causes present, highly likely. And the same if you get six consecutive points going down. So that's what that rule is. Now, your company may use these rules. They may have other rules. They'll probably have more than 4. It doesn't matter. It's all based on probability statistics. So recognize that. And all the rules they use are to help you understand when special causes are suspect. And they may use different numbers than this also, because they may be higher risk or lower risk. So these numbers can definitely change between companies, and that's fine. Okay, let's do an example. Here we have some data. A special cause is suspect if 1 or more points are above the upper control limit or below the lower control limit. Here's my control limits right here, the dark line there. And as you can see, all the points are within the control limits. So what does this suggest? Rule number 1 says, hey, looks like normal cause variation to me. Don't adjust your process or your machine. 2, a special cause is suspect if 8 or more consecutive points are above or below the center line. Notice there's a couple there, 3 there, but we're a long ways away from 8. So rule number 2 says, hey, don't adjust your machine. All this variation you see, it's just normal cause variation. It's from the design of the process. You can't adjust it out. If you want to reduce that, you need to redesign the machine. A special cause is suspect if 1 or more in 20 plotted points lie in the 1/3 outer edge of the chart, 1 sigma outer. This may very well be. I'll have to check that later. A special cause is suspect if movements of 6 or more consecutive points are either up or down, and we obviously don't have that. So rule number 4 would suggest this is just normal cause variability. Don't adjust your machine. Okay, so hopefully that's helpful. Here I did go out 1 sigma outer edge of the chart, drew a line. It does look like there's a special cause there. Usually on these SPC charts, depends on the chart, but we'll plot average on one chart, then we'll have another chart down here for the range. The average tells us if the average of the distribution shifts, and the range chart tells us if the standard deviation has changed. But they usually use the same rules for both charts. So let's look at the range chart. There we have it, one outside the control limits. I put the average and range chart together. These took place in approximately the same time, so I'm really suspicious that a suspect special cause is present, and I can adjust the machine out. Now that's not usually good enough to just adjust it out. You want to find out what caused that special cause so you can go back and correct it so it's less likely to take place next time. And it may be a good thing too, so maybe you want it to happen more often. I don't know, it just depends on what we're looking for, right? Okay. But again, this is the average. This shows if the standard deviation changes. In a normal distribution, you only need two numbers to describe the whole distribution, average and standard deviation. So this keeps track of your whole process from a statistical perspective. They're very powerful, by the way, very, very powerful. And when you do get a suspect special cause, usually the operator will keep running the machine, but the manufacturing engineer, quality engineer, someone will come down, do an investigation on that special cause, document the investigation, hopefully figure out what's going on so they can improve their processes. Well, congratulations, we have completed this short lecture. Hopefully you learned something new that will help you in your career. Remember, if you ever have need of ASQ certification preparation classes, please keep us in mind. Thank you, and have a great day. Goodbye.